All right, so going way back, you guys have been doing this one forever. Simplify these. So 8 over 12. And really in the last unit we were just doing this too, right? So simplifying 8 over 12. Okay, well, I'm looking at the top number and I can see that they're both even numbers. I'm going to divide the top by 2 and the bottom by 2. So we end up getting 4 over 6. So I could have went even more, right? I could have actually divided by 4 on both of those. But that's okay. We'll just do it again. So they're still both even numbers. So I'll divide by 2, divide by 2. So we end up with 2 over 3. Okay. Same with this one. So easy way to look at this, right? They're both even numbers. So I know 2 goes into both of those. So that's going to, I'll divide the top by 2 and the bottom by 2. So that's going to be 17 over 50. And then I can probably stop because 17 is actually a prime number. There's nothing that goes into that, right? So that's as low as we can go. And so forth. I think you guys will be fine. So I'll move on in this one. But we're not going to be doing it, like, not yet anyway. We won't be adding and subtracting. That'll come in like a little bit later lesson. But let's, for good measure, go over that too. So here I'm going to write it out again. So we've got 3 over 4 plus 1 over 2. All right, so when you're adding or subtracting fractions, we need to have a common denominator, right? So the same bottom number. So I'm going to look for numbers that 4 and 2 both go into, right? Well, this one's kind of easy because actually they both go into 4, right? I don't even have to change the 4. I can just multiply the bottom by 2. But you can't just multiply the bottom by 2. Whatever you do to the bottom, you got to do the top. So we got to multiply top and bottom by 2. And then rewriting that, you would have 3 over 4 plus, and then 2 times 1 is 2 over 4. And now we're good to go. We've got same denominator. And then what we do is we just add the tops or whatever the symbol is. If you're subtracting, you subtract the tops. That's going to be 3 plus 2 is 5, and then the bottom stays the same. So it's 5 over 4. Okay, I'll do one more just for good measure here. Let's do the bottom one. So we've got negative 6 over 15 plus negative 6 over 30. All right, so like they just really need to be the same denominator, right? These are already kind of bigger numbers. It actually might be easier instead of, well, we can do it either way. Let's do it the same way we're doing, just to keep it the same. But so we can say, okay, well, I need them to be the same. I'm going to multiply the bottom by 2 and the top by 2. So this becomes negative 6 times 2 is 12 over 30 equals, and then I've still got plus negative 6 over 30. All right, so we got to make sure we go the right way with this now. Negative 12 plus negative 6, that's the same thing as negative 12 minus 6. So that's going to be negative 18 over 30. And then we would simplify that, right? So I can see again that they're both even numbers. So let's just try that. Divide by 2, divide by 2. So we've got negative 9 over 15. And there you go. That's it. All right, multiplying and dividing. So multiplying and dividing are the easy ones. Multiplying and dividing is just straight across. So, or multiplying is anyway. So you just multiply straight across. We go 3 times 1 is 3. 4 times 2 is 8. And that's it. You would simplify if you could, but that we can't on that one. So that's all we do, right? Now, I want to do this one because we could do the same thing, right? I could go 5 times 1 and then 12 times 5, and then I could simplify those. But more and more, we want to start seeing a little bit of a pattern here that if I've got 5 on the top here and I've got 5 on the bottom here, I don't even really need to do that. What I can do is I can actually just simplify those guys. I can go 5 divided by 5 is 1, right? And actually simplify both those to 1. And then this would really become 1 over 12 times, well, 1 over 1, or just 1. And that's a lot easier, right? That's just 1 over 12, right? That just simplified everything. So we're going to be doing quite a lot of that kind of stuff coming up, so that'll be important. Okay, dividing. Dividing is the same thing, but you flip it around. So in this case, right, we could rewrite this as 17 over 50. And then dividing by a fraction, the same as multiplying by the reciprocal. So multiplying by the thing flipped upside down. So we're going to change this to a multiply, and then we're going to flip this upside down, and it'd be 2 over 1 instead. So the reciprocal. Okay. And then that's equal to. Now, again, I could go 17 times 2 and then 50 times 1. But you know what? What I think I'm going to do instead, just to kind of, again, to get kind of used to it, I've got 2 up top and I've got 50 in the bottom. I'm going to simplify those two things. Those are both even numbers. I'm going to cancel that down to 1. And I'm going to call that 25, right? Just dividing them both by 2, right? So this would end up being 17 over 25. You get the same answer either way, though. If you would have went this times 2 would have been 34 over 50, and then that would have simplified down, right? So you get the same answer. Okay, let's move on to the factoring stuff. So factoring. All right, so the first type of factoring. So remember what factoring is, by the way. So factoring means like write this thing as, 2 or more different terms. We want to factor it out into its different parts. So here, let's do this one, and I'll point out what the factors actually are. So factoring this style one, this is like a standard one, is that we just look at the terms. I look at the 6x and I look at 3 and say, okay, what's common to both? What goes into both, right? Well, 3 does, right? I can like 3 goes into 6 and into 3. So that's what we do first. We actually write down the number that went into both of them out front first. So that'd be 3. And then I start my bracket and then I write what's left. So I went 6 divided by 3. That's what you do when you pull it out, right? I'm just pulling a 3 like out of this thing. I'm dividing out a 3. So 6 divided by 3 would be 2x. And then here's a mistake people would make is they'd think the 3 is gone, like you pulled the 3 out, but not really. What we did is we divided by 3. So this 3, so 3 divided by 3, I still got plus 1. So 3, and then here's my factored form, right? So now what are the factors? Well, the factors are things being multiplied together. So one factor you would say is 3, and the other factor is 2x plus 1. So that's what it means to factor it. We wrote it as like a multiplication statement. Okay, so let's do this one quick. So I'm looking at both of these and saying, okay, what's common to both here? Okay, well, what goes into 15 and into 20? Well, 5 does. Okay, so first step, say 5. So it's going to be 5, start a bracket, and then write what we have left. So 15 divided by the 5 I took out is 3x. And then negative 20 divided by 5 is negative 4. So that's it. So that's factored. And just for good measure, I'll show you that we could go the other way too, right? If I had something written like this, you could expand it, right? If you expanded it, then what you'd have there is 5 times 3x is 15x. 5 times negative 4 is negative 20. So factoring is just going the other way from expanding, right? Okay, so now these ones look super confusing, but they're not that bad. We just have more to do, right? So let's look at this one and say, okay, so first off, I'm going to do the numbers. I'm just going to look at the numbers out front and say, okay, what's common to 36, 12, and 24? Okay, well, 12 is, right? 12 goes into all of those, so I'm going to write a 12. And then I'm going to look at my x's and say, okay, what's the biggest x that goes into x squared, x, and x? Well, x does, right? X goes into all of those. X times, or x by itself is x, and then x times x is x squared. So x comes out. And then what's the biggest y that comes out? Which is like the smallest exponent is kind of what you're looking at there, right? So a y can come out. Okay, so same thing. Now we're going to write what we have left now. So 36 divided by the 12 I took out is 3. X squared divided by the x I took out. So remember, x squared divided by x, if you remember, that would be the same thing. So what do you do when you divide exponents? You subtract them, right? That'd be the same thing as just x to the 1. So you can kind of like subtract the exponents when you're doing this. Okay, so that'll be x, just x now, right? And then this was y to the 1, and I took out a y to the 1. So really that's gone. It's like y divided by y, so that's not even there anymore. Or it's like a 1 if you like, but we don't really need it. Okay, so moving on to the next one. 12 divided by the 12 I took out is 1, so it's pretty much gone. X divided by the x I took out is 1, so I don't need to write it. And then y squared divided by the y I took out is y. Okay, moving on to the next one. So 24 divided by the 12 was 2, so and a positive 2. And then the x and the y are both gone, so that's it. So that would be my factored form. It would just be, so there's a factor and there's a factor. Those things are being multiplied together. Okay, 2b, really the same thing. So you know what? I think I'm going to skip that one, but feel free to do that one. Let's get into these ones though, because these are always, this is kind of the bread and butter of what we're doing here. So like the tougher ones. So it says factor each of the following. So we've got x squared plus 4x plus 3. Okay, so we factor these ones a special way. These ones, what we're going to do is once we see that it's like an x squared and then an x and then a constant term on the end, this is how we factor it. We're going to write down our brackets. Okay. Now, one of them, or sorry, they both get an x. So it's going to be an x and an x. And now really what we have to fill in here are the two numbers that are going to be on the back side of this thing. So these numbers need to multiply to the back number and add to the middle number. So that's going to be, okay, so what numbers multiply to 3? Well, really there's only one. There's just 3 and 1. And those could have been the other way. It doesn't matter. It could have been 1 and 3. That doesn't matter. Okay, so 3 and 1. Now they need to add to 4. Okay, well that's easy then. So it'd be positive 3 and positive 1. And that's it. So there's my factors. So there's a factor and there's a factor. All right, let's do the next one. So 6. So in this one, again, we're going to write down our brackets. They both get an x. And we're looking for numbers that multiply to 6 and add to 5. So in this one, it could be 6 and 1, or it could be 2 and 3, right? Those are the options that we have. So I'd look at the 6 and 1, and I'd say, okay, well, maybe, right? But this isn't going to work out well here, because if this is 6 and this is 1 for our numbers, then I'd say, okay, if they were both positive, right, then that would multiply to positive 6. Or if they were both negative, that would work too. But there's no way I'm getting from like positive 6 and positive 1, right? 6 plus 1 is 7, not 5, right? So it looks like the numbers we got to use here are actually 2 and 3. So plus 2 and plus 3. So that'll work out. So that's going to be 2 times 3 is 6, and 2 plus 3 is 5. So those are factors. Okay, next one. So now, this one looks scary, but it's not going to be too bad. Usually these ones where there's a number out front are going to be really tough for us. Like we're not going to be able to actually 30-2, we don't really even have to do those. It's more of like a 30-1 one. But what we can do, this one actually won't be that bad, is that we should always want to see, is there something that we can factor out first? Is there something common to all three of those that we can take out? Okay, so let's look at it. So we got 2, 10, and 48. All right, so 2, 10, and 48. So 2 goes into all of those things, right? And that's it. So then write what we have left. So we'd have x squared after we took that out. And then negative 10 divided by the 2 we took out is going to be negative 5x. And then negative 48 divided by 2 is going to be negative 24. All right, so that actually made things a lot simpler, because now this 2 just kind of hangs out for the rest of it. So this is going to be 2, but then this part, I'm going to factor it just like I did above. So I'm going to throw my brackets down. They both get next. And now I'm looking for things that multiply to 24 and add to 5, right? I kind of just forget about the negatives for a second and say, okay, multiply to 24, add to 5. All right, so I started thinking, well, what about like 6 and 4? All right, so they multiply to 24. But there's no way I'm getting from 6 and 4, like adding or subtracting to 5, right? So that can't be it. So then I'll say, okay, what about 8 and 3? And yeah, that's promising, right? Because 8 minus 3 would give me 5. So I'm in the right ballpark here. So let's write them down. So it's going to be 8 and 3 are the two that we're kind of looking at. And they need to multiply to a negative number. Okay, so to multiply to a negative number, one's got to be positive and one's got to be negative. So we got to figure out which one's which. So in this case, there's only 50-50 chance, right, to mess this up. Let's say that I said this one was negative and this one's positive, right? So that would multiply to negative 24, and that's good. But now I look and say, okay, negative 3 plus 8, that's 5, not negative 5. Okay, so what happened there is I just did it backwards, right? So change the sign. So this must have been negative 8 and positive 3. All right, so then, yeah, this negative 24, and those would add to negative 5. Okay, B, again, is going to be very similar. So I'll let you guys look at that one. Yeah, we'll do 5 because it'll be similar too, but we'll be able to do it. So, okay, so let's do 5. So again, I'm looking at this being like, well, x to the power of 3. We haven't even talked about that, right? But here's what we always want to do first. You want to see, okay, is there anything that's common to all 3 that I can factor out of everything here? And it looks like, well, they're all even numbers, right? So I know 2 can come out. So here, let's write that down. So 2 comes out. And I can also see that there's an x in every one of them. So the biggest x I can take out is just x. And then I'll start my bracket and write what I have left. So I'm going to have just x squared plus, and then 10 divided by the 2 I took out is 5x. And then the 12 becomes 6, right? Because divided by 2. So 6, and that x is gone. So, oh, we've already actually done this one. So we've got left is 2x. And then this I can just factor like I did above. So it's going to be brackets. They both get an x. And then we already did this. This is plus 2 and plus 3 from above. Okay. So that's that one. So moving on here. Now, I actually just left this one on here to kind of show you the type of one that we won't do. And that's this style. So this one, right? I see that there is a 3 out front, right? And that makes things actually quite a bit more difficult. And the reason for it is because I can't just say, okay, this one's an x and this one's an x. Because actually what'll happen is this one's going to be 3x and this one's going to be an x, right? In the end there. And that just kind of messes things up. And there is a whole way of doing this that, we could still do. But to tell you the truth, in 30-2, we don't got to worry about it. So I'll actually let you guys just cross those out. We're not going to be doing any of those guys. So, but these ones we will. You guys will have to do this type of question. So again, this one looks tough. It's actually really easy though, once you recognize it. Oh, starting to glitch out. All right, just gotta wait for it. There we go. All right, so what this one is it's called a difference of squares. All right, and where it gets that name is because we are subtracting, hence the name difference, right? That we're subtracting those things. And the difference of squares part comes from, well, that's a perfect square, right? 49 is 7 times 7. And x squared is x times x. So, and then 81 is 9 times 9. So they're all perfect squares. So the way we factor these is we write down our brackets. And then we look at the first one and I say, okay, well, what number gave me 49? Well, that came from going 7 times 7, right? The square root of 49. So I just put the square root of 49 into both. And then how did I get that x out of this thing? Well, I got that x out of here by going x times x. So the first part is going to be 7x. And then the last part here, the last number, square root of 81 is 9. And then this part's nice because it just, as long as you remember it, when you have a difference of squares, one is a negative and one is a positive. And that's it. That's your answer. Let's expand this too. I just want you to see why that worked, right? So let's go back the other way. So if I went 7 times 7, well, here, we'll do the whole thing. We'll do the rainbow. So 7 times 7 is 49. So we're going to have 49x squared. See that one? The same thing. And then 7 times 9. So we're going to have, and it's positive, so we're going to have plus 63. And then don't forget the x, right? Because it was 7x. And then we do it again, really, but now it's negative. So it's going to be minus 63x. And then negative 9 times 9 is negative 81. Well, what happens here? Look at our two middle terms. I've got plus 63, minus 63. Those things cancel. So in the end, this all just turned into 49x squared minus 81. That's why that worked to just go 1 minus and 1 positive, right? That was the whole point of that. Okay. All right, let's do this one too, because this one doesn't look like they're perfect squares, right? That's like kind of looking like I have a problem here. But what we can do, what you should always do, make sure you check to see, okay, is there anything common to both of these, right? So I look and say, okay, well, that's a 5. And 80 ends in a 0, so that's divisible by 5 too. So we can say, okay, well, that's going to be, we'll take out a 5, or that'd be one of our factors. So 5x to the 4, and then minus, well, 16. Well, that's a good sign. 16 is a perfect square, right? So I'm in the right ballpark. Now, the 5 just continues on, and then this part, I'm going to factor it like I did the other one. So this will be, they both get brackets. Now, what do I put here, though? Like, so remember, it's going to be the square root of that. So let's remember this, that the square root of x to the 4, well, that came from going x squared times x squared, right? That gives me x to the 4. When you've got the exponents with the, with an even exponent there, it's always going to be half, right? That'll always be the one that goes in. So if this would have been x to the 6, well, then x to the 6 could have been made up by going x to the 3 times x to the 3. And that's because you add exponents, right, when you're multiplying those. So it's always going to be half of that even one, okay? So here, this will be x to the 2, x to the 2, they both get 1. And then the square root of 16 is 4, so they'll both get a 4. And then one's a plus, one's a minus. And then, ooh, this one is a really tricky one because we can actually make this a little bit simpler, because we ended up making a hidden little difference of squares in here. So yeah, this is a really tricky guy. So then we could keep going. So this would be 5 times x squared plus 4, which is nothing, by the way, because we're not subtracting there, we're adding. So that's not a difference of squares. But then this one was. So then we could say, okay, we'll make our brackets again for both of them. And square root of x squared is just x, so they both get an x. Square root of 4 is 2, so they both get a 2. One's a plus, and one's a minus. All right, so that would be fully factored with 4 factors there. Okay. Whew. All right, so last one here. Oh, you know what? This one isn't going to work out very nicely. So, you know what? I think that's good. I think you guys will be good there. These type of ones, what you can do is, well, we can do this one. So yeah, this will work out fine. We've got, this is another special type where we've got x squared and y squared on the ends, right? So 2 different variables on the ends. And then it's x and y in the middle. Okay, so the way that this is going to work, we can factor it very similarly. So again, we just get to put down our brackets. And it'll be an x and an x is what's going to give us that x squared. But then what changes about this one is now on the end of this thing, we're going to have a y and a y. Right? That's what's giving us that y squared. But now we're still going to do the same thing. We're going to say, okay, what numbers multiply to 33 and add to 14? Okay, well, that's just 11 and 3. So 11 and 3, and they're both positive. So there you go. That'd be it. That'd be your answer in that one. Okay, so that's it for the review, and then we'll I'll have some room there, but I think we're good. So then we'll go over 4.1, 4.2 later.